comes near to the user, obviously it detects it and responds to the system, the frequency. There is, you can see here, RFID reader and RFID transponder. So depends upon the respective RFID. Whenever we go near to the RFID, whenever it is like a echo based, when I send a signal, if it reacts to my frequency, it gives the echo. So it is basically RFID based technology. Another one is called near field communication. Ever you seen the near field communication? Anybody? Many of you may have seen this. You see your credit card or debit card, it is given over there some sort of the waves. Yes? You need not to swipe your credit card or debit card. You can show just like that. You might have seen this one, you might have used also, but you might have not aware of that what exactly happens. And we call it as a near field communication. There are two things, it will be having only the data storage, like SIM card kind of thing. Some data will be stored, the memory will be there. Whenever some signal comes towards it, it reacts and gives the data to the scanner. So like that you might have given the spiking mission, that fellow whenever you start, that will starts the transmission and gets an echo back and collects your data, accordingly payment will happen. You might have used it. That is called the near field technology, the near field communication, that also can be used for the IoT. Another one is called ultra wideband technology. It is basically technology uses the millimeter wave. We call it the millimeter wave technology. Wideband frequency will be from one frequency to another. Let me ask many of your electronic students, what is a narrow band? What is a wideband? Narrow band communication, wideband communication. Madam also can tell. Madam, narrow band and wideband. You might have seen that FM radio. Tell me one FM radio channel number and their frequency. Huh? Only one. Narrow band means service given to only one channel. Only dedicated channel, dedicated single frequency. Wideband means I can use this frequency, this frequency, this frequency as well as this frequency. So it is spreading. All our television channels will be using narrow band, single band. Every channel will be given one frequency. Every FM radio channel will be given one frequency. But your mobile phone is basically works on wideband. Every time you will not be given dedicated frequency, every user cannot be given. Whenever channel is available, from the available channel, one channel will be given to us. So this is ultra wideband, means it is beyond the frequencies are available but smallest distance. It will not affect any other communication. Generally we use this one. Currently we are not using this, but it was expected to be used for inside assembling of computers or big machines like aircraft. There will be many devices will be there. Always we cannot use cable for everything, and we wanted to convert that one by using the ultra wideband. The shortest, very short distance communication. Another one is called Zigbee. It is the basically conversion of the Bluetooth into the maximum range, whatever the possible range. The possible range was with the help of Zigbee. It is like extension of Bluetooth without any combination, anyone to anyone. Again, same thing, the 15.4 only. So Zigbee was basically created any kind of formation of the network, starting with the star network, cluster network or the mesh network, any formation to any formation. So it was a creation of the network to network, connecting many devices. So for our IoT sensors also the same thing. You can create any sensor to any sensor, any form to any form. So that is basically the advantage for the Zigbee. Zigbee is one of the most popularly used technology for the IoT. You know, tomorrow all of you third years, I think, many of you third years. In final year project you will realize that. So I don't have time, I could have demonstrated it. But you can realize tomorrow when you go to the final year project, then many of you may be doing IoT projects. You can create any network formation where you will be using only Zigbee. Another one is called Z-Wave. This is another, the technology, Z-wave technology. It's like a wave technology where it uses, they have made by the Genesis. But here the problem with this Z-wave is it uses the licensed frequency. Whatever the communication you would like to have, currently we cannot use any licensed frequency for Wi-Fi, Bluetooth, BLE or Zigbee, everything based on the open frequencies we call ISM band frequency. Industrial, scientific and medical band frequency, free licenses. But this Z-wave is not the free license based. It needs a permanent, a purchased license of the frequencies. So whenever we have it, we can make it. Because I am making my own private IoT, I can create my own license, my own frequency, so that no one will interfere with me, and that can be used with the Z-wave. Another one is called HART frequency. It is similar to the HART technology. ISA 100, another same technology, it's a device technology. Another technique is called low power wide area technology. So depends upon type of distance, short distance, cellular network as well as the low power wireless access. Low power wireless. So depends upon where, if I would like to go from 1 kilometer to 10 kilometers, either I use wireless network or wireless cellular network, either I can use the low power wireless access. There are two kinds of low power wireless technologies are there. One is called LoRa, long range. Another one is called Sigfox. These are the two technologies available for more than 1 kilometer to the 10 kilometer. But for the cellular communication, frequency signal cannot be used for the IoT. We convert them into the LoRa as well as Sigfox. So same thing here, using the frequencies of our own choice and dedicated frequencies also. The LoRa, basically LoRa WAN, LoRa long range wide area network, we can create our own choice of communication network. By using this communication network, we can create our personal or public IoT network. By using this public and private IoT network, we can create our own. For example, my farm is my farm, my home is my home. So I will not depend on any public IP, public frequencies. I need a dedicated frequencies for me. At that point of time, I use generally this LoRa as well as Sigfox. So again, I don't want to go into the details. Sigfox, with Sigfox, the same thing again. Connect various sensors here. Collect the data by using the network. Same again, broker, cloud, then again the users. Same, but it is again the licensed one. Sigfox is the configuration, the technology or software, where it uses the licensed band for long range, low power technology. You can see, my dear friends, frequencies are downlink 600 kHz, uplink 100 kHz. Data rate 100 kHz downlink, uplink is 100 bits per second. So it uses a dedicated and licensed frequencies and the dedicated bands. Another one is called narrow band IoT model. So currently we see the wide band as well as the narrow band. For one device, one frequency. One sensor, one frequency. If I use the wideband frequency, which sensor giving me data, I don't know. If I collect the data from one sensor, known sensor to me, I know that he is generating that frequency. So that's why we will be making use of a dedicated frequencies of respective sensor that is made available with the narrowband IoT. Standard is also made for this one. You can see here, my dear friends, dedicated devices, dedicated frequencies. Dedicated devices, dedicated, see here, the frequencies are allocated to each and every application. It's called narrowband. Each and every sensor will use dedicated frequencies. Operation also can be having the three kinds of band. It is in-band, God-band and stand-alone. In-band means only one frequency. God-band is divide the frequency with the spacing, as well as the stand-alone means only single frequency using by everybody. Stand-alone. So the band of it depends upon again for a dedicated respective band 1, 0, 1, 2, 3 and n depends upon the frequency and its divisions. Usable area, see one thing is very important here. As I have given an example to you, private IoT as well as a public IoT. Private IoT is my own home automation. Public IoT is anybody can access, like a railway station, Wi-Fi access, for example. Railway station data, as madam said that Google Maps is public. Anybody can see that what is the traffic available over there, publicly. But my home, what is happening, what is there in my fridge, is none of somebody's business. So I need to know what is the privatization, what is the public requirement. So in that particular case, what is the usable area? Where I can use a private narrowband, where I can use the public wideband. I can use for my application completely the private, so that you can use the narrowband, fridge one frequency, AC one frequency, washing machine another frequency, because dedicatedly can be given to that. But in the public applications, cannot be given like that. Everybody is going to access, so that the frequency must be, for radio FM, red FM, everybody will access that. It's the public. It should be known to everybody. But my private one must not be known to everybody until unless my device. So in that particular case, we have to look into that. Depends upon usable area where we can use what kind of frequency, what kind of devices for public IoT and the private IoT. In that particular case, so where we have to look into that, the metering, tracking and monitoring and control. So we have to classify them into these requirements, the metering, tracking as well as control. Accordingly, we have to develop the respective devices for the respective application. So implementation technology is the same thing for low power wireless access. So generally we are using the LoRa as well as Zigbee. And the last one is called the 5G communication. It is basically, we call it as medium range communication only, but it is long range communication also. So one of the most basic example of the IoT is making use of the 5G. 5G is basically completely looks like to be IoT based network, but it is for communication, not only for communication, combining all IoT devices. All IoT devices will be generally working in a very small distance. So generally 5G is divided into two types, private network, public network. We are also calling it as IoT into the private IoT, public IoT. The future, as by using the 5G communication, you will be creating your own communication network. Or we can also make use of our communication network to everybody also. So now the same thing can be adaptable to the IoT. That's why we are discussing the 5G mobile communication technology. So you can see here, my dear friends, there are different configuration of the IoT in the name of the massive MIMO, ultra wideband MIMO, then the ultra dense sense MIMO, multi-rack MIMO and the 5G OGM. So we can configure the 5G in different configuration, but all the configuration we can make use of the IoT. So basic difference between, if you look into the 5G, starting from 1G to the 5G, only the difference is very high speed, but distance will be smaller. How much faster you run? If you run fastly, long distance can you run? Not possible. So that the 5G is a short distance communication. I can run very fastly, but very short distance. But slowly you can walk kilometers. Small, that's only the configuration. So I don't want to go into details of the 5G, because 5G for the IoT can be used, whatever the application we discussed for the IoT, everything is here. Starting with industry, environment, agriculture, transport and logistics, utilities, smart cities, smart buildings, as well as the consumer application. Everything can be created by using the IoT based 5G for the IoT. So 5G will be the boon for the IoT technology, and it can be used for everything, and we call it as the 5G IoT. As I wanted to give small thing here, technical characteristics of 5G for we call it as the 5G IoT, that can be massive IoT configuration, mission critical applications of the 5G, and enhanced mobile broadband. But you can look into that, the huge number of devices can be connected here. The short time to the IoT interact, and last one is the consultation, telemedicine, and these things in the name of the enhanced mobile broadband. So where you need to have the terabyte, but it will be smallest distance. So in this particular case, the 5G will be most optimal. You can also use Bluetooth, you can also use Wi-Fi, but there are some limitations of all other technologies, but they are becoming very older now. Now we can make use of the 5G for connecting or configuring all our IoT devices, as because there are many sensors will generate the data in many forms, many variants, so many sizes. So in that particular case, 5G will support us with varied configuration for smallest distance. So in that case, the 5G is most optimal for the IoT 2.0 as industrial IoT or cognitive IoT. So this is all about the IoT today and tomorrow. Okay, thank you very much for listening to me, and thank you very much, sir, for giving me this opportunity. Thank you very much, all of you, including madams and students. Thank you.
All of you, very